Hey, Craig here. So I'm going to be starting a fairly large job here pretty soon that's going to require me to curve 1/8" aluminum. This is kind of the prototype that I had made up. I made this on the slip roll, but the slip roll is only made for 16 gauge. It just took me a really long time to do this. So basically what I need to do is I need to make a die that will be able to form these in one shot. What I'm going to do is similar to another video that I did, is basically a test. I'm going to test to see if I can curve this in a smaller size before I make the main die. Okay, I've already got the piece for it in the vise. I've already faced off both sides, squared it up, mounted in the vise on the parallels. So the first tool is going to be a 3D adaptive toolpath, a 3/8 3-flute roughing end mill, 7,000 RPM, 63 inches a minute. The depth of cut is going to be around 3/8 of an inch with a width of cut of 80 thousandths. Well, that actually turned out pretty nice, just like that. That was a 10 thousandths fine step down with, I think, 10 thousandths stock left. Okay, so the next tool is going to be a parallel tool path, finishing tool path. This is a 1/2" 3-flute ball end mill. I'll be running this at 7,000 RPM, 63 inches a minute. The step over is going to be 10 thousandths of an inch. Alright, well that's the bottom part of the die. Now I'm going to go ahead and make the top part. Okay, well it seemed to have left some flat spots over here. I'm not sure if the parallel tool path just wasn't going past far enough to remove that material, or what the deal was. I tried to create a chamfer tool path to cut that off, but for some reason I can't get Fusion 360 to generate a tool path on this edge. So I'm going to attempt to do a manual chamfer here. Okay, well that took quite a bit of chamfering there to finally get rid of that curved up edge there. Alright, but it should still be good for the test. Alright, now originally I was just going to try and use it just like this, but I decided that since this is curved, it's going to be a little difficult to put in the press that way. So I'm actually going to machine a hole in the back to kind of hold this piece level. So I just set the workpiece down on the bottom of the vise like that, and now I'm getting ready to go ahead and bore the hole there. I'm just going to use Conversational and Path Pilot, the circular pocket tool. 7,000 RPM, 63 inches a minute, 60,000 step over. I'm not really sure about the ramping on this, so I'm just going really conservative, 10,000s, 100,000s depth of cut. Actually, the location for the pocket is in mill drill, drill tap. So I've never done this before, so I'm assuming that's going to work. Oh well, I forgot to change from manual to auto on the spindle before I started, and it engaged so fast. I guess my Z start, my Z clear was so close. So, right. Okay, first I'm going to start off with a piece of 16 gauge aluminum. Well, it worked, but you can see there's definitely a significant amount of spring back on that. That's one of the things I have to try to figure out, is how much spring back I'm going to get. So I've got to figure out, this is a 5-inch diameter. And I don't know, I have to check this. This may be 6-inch. Alright, the next thing is going to be a piece of steel here. See how the steel works. Okay, as I expected, there's less spring back in the steel, but actually it worked out really, really nice. That's cool. Okay, now I'm going to go ahead and test this on 1/8-inch aluminum. This is 5000 series aluminum, which bends easier. As you can see, there's a little bit of spring back there, but when I compared it to my diameter gauges, this is a 5.5-inch diameter gauge. It's pretty close to 5.5, so yeah, it's just springing back a little bit. That gives me a better idea of how much I have to adjust the die. Right, well, that worked out pretty good. It actually sits perfectly flat too. So, right, well, let's push this and see if I can do something thicker. Alright, well, let's see if this can handle 3/16 aluminum. Yep. Alright, well, I've got a piece of 1/8-inch steel here. I'm kind of thinking it's cold rolled, so this may be a little difficult. Hot rolled is usually a little easier to bend, but let's see what happens. Right, well that actually bent pretty easy. Maybe I'll try a 3/16 steel. Okay, here goes 3/16 hot rolled. Alright, 1/4-inch hot rolled steel. Okay, well, I wouldn't have believed that, but it worked. Cool. Alright, well, that went far better than I could have ever imagined. Had no idea that I'd be able to get up to 1/4-inch steel plate on this thing, on an aluminum die. Can definitely handle the job that I'm going to be working on, the 1/8-inch aluminum. Obviously, depending upon the thickness and the type of material and what, curve you want on it, you're going to have different radius diameters cut into different dies, but you can kind of get an idea of the kind of things that you can actually make with dies, so alright, cool. Alright, well, in future videos I'm going to be going over the making of the permanent die, the actual die that I'll use on my press die system. Alright, well, if you like this video, I'd appreciate the thumbs up. If you'd like to subscribe, there should be a subscribe button here, and some other videos you might like to watch down below. If you have any comments, feel free to leave them down below. And as always, thanks for watching.